Welcome to the world of the normal distribution. By now you should have watched some videos about this situation, and what we have here is what's often referred to as the empirical rule. So, normal distribution. Most stuff is clustered around the mean, whether these are, whatever the data is about, most of it is clustered around the mean. The further away from the mean you get, the less percentage of the data you will find on either side. Now, Greek letters here. This is the Greek letter mu, which is often used, it's mu, which is often used to represent the mean. So the mean is mu, and then this is the Greek letter sigma, which is used for standard deviation. So if you go add one standard deviation bigger than the mean, another standard deviation, so 2 standard deviations, 3 standard deviations, 4 standard deviations. Or you can subtract a standard deviation or 2 or 3 or 4. So what you see here in this salmon color, 34 roughly, 34 plus 34, 68. 68% of all normally distributed data should be clustered within 1 standard deviation of the mean. If you go another standard deviation out, you can add another about 13.5, that's about 27. So 68 plus 27 in purple, that would give you another, that would give you about 95% of the data. And then another 2, 4 on each side. So about 99% of the data, roughly, is within 3 standard deviations of the mean. Now, I would encourage you to take a picture of this, print this, put it on another screen, Google it. You can find another image similar to this, because this is something you'll want to refer to frequently. In your problem situation, you had this situation. You might want to pause the video now if you don't have this in front of you. But this is the situation that we're going to work through right now. All right, in the first case, suppose the mean typical American teenager spends doing homework is 4.2 hours. Assume the standard deviation is 0.9, 9/10 of an hour. And assume this variable of time spent doing homework is normally distributed. So the way you would start is you should have a piece of paper and a pencil, and you would do a quick sketch of a normal distribution bell curve. I just Google imaged this one and threw it on there. But then what you would want to place on it is on this horizontal axis. Think of it as a number line. This is just a number line where in the middle you have that mu, that mean, in our case is 4.2 hours. And then 1 standard deviation bigger. With a standard deviation of 0.9, we want to add 0.9. 4.2 plus 0.9 is 5.1. And then add another 0.9. That would be 6.0. If we wanted to go another standard deviation, you would add another 0.9, which would take us to 6.9. I'm not going to. Or on this side of the mean, just like on a number line, we want to go less than the 4.2. So go 4.2 minus 0.9. Oh, I did do 6.9. Ha! Surprised myself. And then minus 0.9 would take you to 2.4, and then minus 0.9 would take you to 1.5. So notice, mean of 4.2, a standard deviation of 0.9. If you start over here at 1.5 and add 0.9, add 0.9, add 0.9, add 0.9, add 0.9, add 0.9, you get this nice number line. So what we're saying is most of American teenagers, 68% of them in fact, do spend homework time that's between 3.3 and 5.1 hours, 1 standard deviation either side of the mean. So what we would do is maybe shade that in. I know it's terrible with my PowerPoint pen, but if I shaded all of that in, 3.3 to 5.1 hours, we would say 68% of American teenagers spend that much time doing homework. If you go from 2.4 to 6.0, that would be the 95%. If we go 1.5 to 6.9, that would be about 99%. Based on this data, 99% of American teenagers spend between 1.5 and 6.9 hours doing homework. That's what this means. This is what it means. All right, you were asked to specifically figure out who spends less than 3.5 hours. So 3.5 on this number line doesn't come out cleanly, but 3.5 would be right about here. Just a little bit to the right of 3.3, less than the 4.2. And so it's not a nice clean break, But if you look back at that first slide, you could kind of get an estimation. Remember, there was 34% of all the data was in here. So we're like a sliver of that. Maybe we're like, I don't know, 10%. And then into here and into here, if you look back at that slide and kind of add up all the percentages, I'm going to say that's going to add up to maybe a little more than 16%. Just ballparking, you guys. I'm not doing any computations. I'm just thinking back. In fact, let me go back there really quick. I'm going back to this thing and saying that my 3.5 was somewhere in here. And so what percentage of the, no, it wasn't, it was somewhere in here. What percentage of the American teenagers spent less than that on their homework? So I said, well, you know, it's like 13, 15, maybe a little bit more. I'm just kind of ballparking all of that area to be around 16%. Now, here's the good news. I got good news. You don't have to guess. There is a tool that will tell you exactly. Here's the tool. Here's the website. And I have to get my pointer back. Where is it? I know I made it a video. Oh, there it goes. So in this website, you just type in the mean. You type in the standard deviation. And then you just pretty much select the buttons that you want to do what you want it to do. We wanted to know what percentage was less than 3.5, so below 3.5 hours. And then when you click recalculate, it'll tell you about 0.218, so about 22%. About 22% of American teenagers spend below 3.5 hours doing homework. Now, all you need to know when you go to this website is you just have to type in the appropriate mean and the appropriate standard deviation for our particular situation, and then just figure out, are we looking at above, below, in between, or outside? In our case, below 3.5. Click recalculate, and you're good to go. So we'll practice using this. You should go get that up on your computer as well. In fact, you could pause the video now. If you're like, oh, I got some more information, and go back and answer those other questions, feel free. Pause and go answer, and then come back and check your work. But on the second one, the question was, find the percentage of American teenagers who spend more than, let me get my marker here again, who spend more than 3.5 hours doing homework. So notice what I did here, same mean and standard deviation, but now I want more than or above 3.5. And so there's the 3.5 on the number line, just a little bit to the right of 3.3, and we want everything above that. And so the computer figures that out for you. Thank you so much, computer. I hit recalculate and it says about 78%. Now, if you remember back on the previous one, it was about 22% were less than 3.5 hours of homework. 78 is more than 3.5, and that should make some sense to you because 22, roughly 22, and roughly 78 add up to 100%. There's nothing more. You can either be less than or more than 3.5, and so together these two should add up to 100%, and they do. Or how about this one? What about a student indicates they spent 8 hours doing homework one week? What do you think? So look at this in terms of our normal distribution with a mean of 4.2 and a standard deviation of 0.9 hours, 9/10 of an hour. One standard deviation would be 5.1, two standard deviations, three standard deviations was 6.9, four standard deviations. This person is way off the charts. In fact, look at what it says here. What's the percentage of people who worked more than above 8 hours of doing homework? Nobody. So what do you think of this claim? Valid or questionable? We would say it's very questionable. Based on the data, it's very questionable that anybody spent 8 hours doing homework because you would be like 1, 2, 3, 4, or 5 standard deviations above the mean. How about this one? Suppose the mean times teenager sent homework is, but the standard deviation is 2.1 hours. Now, if we change the standard deviation to 2.1 hours, what that does is it spreads things out more. Remember, the greater the standard deviation, the more spread out the data. So here's our mean, or mu, of 4.2. But now we add 2.1. Add 2.1. Add 2.1. Subtract 2.1. Subtract 2.1. Obviously, we get below 0, which is not reasonable in this case. But nonetheless, that's what the data would say if we had a standard deviation of 2.1. So what does that tell us compared to the original data? It just means that we have a more spread out data set. There's more extremes. We have people spending lots of hours on homework, and we have people spending not so lots of hours on homework. Where in the 0.9, we have more consistency around that mean. So now, what do you think of the students' claim that they spent 8 hours doing homework? Well, now it's a little bit more reasonable. At least 8 hours of doing homework, which would be somewhere in here. At least 8 hours of doing homework is somewhere on the charts. So notice I changed the standard deviation to 2.1. And I'm just thinking about the student's claim of, I spent 8 hours. Well, what percentage of people were 8 hours or above? Well, it's 0.035, so like 3.5%. Okay, still questionable because only 3.5% of students worked 8 hours or more, but a lot less questionable than it was before. And this is where we're at. This is what we can say. We can't say with certainty. If some student told you this claim, we wouldn't just say, you liar. We would just say, well, does that seem reasonable or not? And it's, compared to the previous, more reasonable, but still only 3.5% of the students actually worked 8 hours or more on homework. And so maybe you would claim that this student's claim is still questionable. All right, now go back to work, try some more. You have some more to do. Have fun.